G'day guys, take two. As soon as I started recording, I had a bit of a coughing fit. Oh God. Anyway, one of our customers has sent this in with his detector. He says his detector cannot pick up that piece of gold. And I think he may have been comparing his detector with a VLF. And the VLF will, in most cases, if it's a high frequency machine, will scream on anything. But his 4500 won't pick this up. So that's how it come. It's in there with a whole heap of write-up. I just turned that around not to put his name and address on this. But anyway, I have another standard 45. This came in for repair. And it's been repaired and it works really well. It's got no modification done to it. It's just standard 45. And if I undo that, I can turn that around a bit more. There we go. So I've got it sitting on the bench. I'll just turn up its, no, it's not on. I've got the audio amp on, but the detector's not on. What I'll do, I'll just reset this detector to factory defaults. So I've got the microphone over near the speaker, so you should be able to hear it quite easy. Okay, reset to factory defaults. Like I say, this has been repaired. It was noisy, now it's very quiet, so it's working really well. And if we have a look at the front, we don't want to pull the coil off. So on the front panel here, it's in deep. We've got it in enhance. I'll put it in normal mode, just for the hell of it. I'll put it in fixed, it's not in tracking, and we're in cancel. We're using a 5x10 double D coil. So what I'll do, I'll just bend this back up. You can see me do this, I think. Up there the coil is. I'll just move it a little bit closer. There it is. So if I get this piece of gold, stock standard 4500, will not pick this up. Definitely a stock standard 4500. So what we'll do, how about we put it into special? That'll be sensitive extra, I think. Hang on, I better check. Yeah, it is in special extra, so we should get a decent response from that on this. Go back around again. Basically got to scrape the coil to get the target. Let's try enhance. Dear me. I just had some toasties and I think the carbs never agree with me for some reason. Anyway, bit of gold. Scrape the coil again, and that's enhance. Now this is very, very peculiar. That's a pretty sizable bit of gold. Damn it, gas lift chair, it's gone all the way down. Up again you go. On a gas lift chair, if you lean on the side on some of these, because they're not very well made, of course. You lean on the side and the seal pushes over and it just goes straight down. It's really annoying. Anyway, that is a 45. Like I say, that's stock standard. No variable gain. Oops, I don't want to show the customer's name on it. Just a standard 45, and a B8000 serial number on it, if that's any use to anybody. Anyway, we'll get that out of my face. By the way, to the fellow that had the noisy detector, it's obviously fixed. But okay, we'll get this one here. And I'll put that around a bit. I'm going to take the sticky tape off. And if I had longer fingernails, it'd be better. But okay. Sometimes when I take this off, I have had surprises wrapped up in the bubble wrap. You can only guess what that is, but I've got to get this bit here off. Wow, okay. He's put an extender on the variable gain control. Yeah, well, I suppose it makes it easier to get to, but yeah, there it is. So obviously he knows who's his detector is with at the moment, because that's his detector. No names on it. No, just some Velcro. Good. Okay, we'll plug it in. We'll give it a test. Plug in some power. Okay, I'll just set it to factory default for the fun of it. Okay. Bit more threshold. It's a bit quiet. So we'll have a look on the front. What do we got? Leave it in fixed. We'll put it in cancel. Leave it in normal timings and deep. Now this is a modified detector, and we'll see what it does. I don't know where we got the gain. The gain is right down. I was trying to get the noise to about the same as what the other one was. So it's backing off the gain a bit. Probably still a little bit too much. Well, I don't know frequency wise where it is either, so we'll just see if it can pick up this gold in normal mode. I don't know if it can. I've got no idea at the moment, but we'll see. It's just an experiment. Okay, there's that bit of gold. No, doesn't pick it up in normal mode either. Okay, let's try this. I'll stick it into enhance. It's weak as water. Weak as water. These detectors do not want to pick up this size gold. What I'll do on this though, this has variable frequency. Yeah. I wish these things were automated, it'd be easier. This has variable frequency, so what I'll do, the frequency, or should I say, the pulse lengths on this at the moment are pretty well standard, probably around about 36 microseconds. So what we'll do, we'll speed it up by using, well, I think this one's got variable frequency. I'm pretty sure, we'll soon find out. Manual tuning, it's on 128. Yep, it's got variable frequency, because if you adjust the frequency in basically the manual tuning, and it makes that noise, and the higher in frequency you go, the faster that noise happens. The more pitch you get on it, that'll indicate the detector's been modified for variable frequency. Oh, okay, I've got this on 255, and we'll try it out on this undetectable piece of gold. A slight improvement. That was in special, extra. We'll try enhance. So it's come up a bit, but we'll give it some more gain. We'll just see if we're on noise before. I've got the gain at about half. So I'll just do a little bit. I don't want to push it to make it too noisy because that'll just defeat the exercise. But we'll try again. That's an improvement, but we'll try in normal timings again. I shouldn't tighten this up, should I? I'll leave it loose. So normal timings. Barely. Okay, give it some more gain. We'll just see, just push it a little bit. That's full gain. So that's normal timing, so we can actually get it. Before we couldn't. And I'll just put this into enhance. So the detector is in enhance. Yeah. So that's where we are at with that. Have a good look at it. It is just about non-detectable. I bet if I went and got a gold monster, I bet you it would ping like hell on that. Should actually try that, shouldn't I? What else can I try it on? What's that there? No, bear with me. You can stare at that 4500. I will go and get a gold monster. So I don't keep them in my workroom, I won't be able to move. So okay, I've got a gold monster. I'll get in and shut the door. Occasionally you get targets and they look large, but you can't detect them. So anyway, I have a gold monster. And I was out actually doing some tests on this one, so it's a bit, it's, on its shaft and everything, it's a bit, anyway, we'll just fire it up. Hopefully I don't poke it too close to anything I shouldn't. Oops. Okay, I'll put it down this way. It's going to get a little bit of pippy interference from lights and things, but we're only interested in this end of it, so we'll see how we go. Okay, it's in manual, but we'll try it anyway. I'll do it side on. You can see. Yep. I'll just turn this off. Okay, so the gold monster picks up that piece of gold really, really easily. And even though, if I take this off here, the coils basically the same size, aren't they? So PIs on some gold targets will not pick it up. It just, the size, the shape, it's falling in, or falling outside the range, I should say, of being able to have the detector pick up the eddy currents generated by that piece of gold. But on the VLF detector, it's causing a phase change, which is easy to detect. So the gold monster wins on that, but definitely will not win on depth on big nuggets. So horses for courses again. But it's very interesting. I've had it before. I know a fellow in Maryborough that he found a brass button, and it was fairly big. Actually, I've got something here. I could probably give you an idea of the size of it. A little yellow ferrite core. It would have been about that diameter, that sort of size, and it just would not respond to a 4500 detector in any way, shape, or form. It just would not. It was brass. It had a black oxide layer over it because it'd been out in the weather. And we get a VLF detector, a whole Garrett, and just pew, pew over it. But the PI wouldn't pick it up. And it was a big target. It's just really strange. So even on that type of gold, even with a modified detector cranked up, it makes very little difference on that type of gold for some reason. Whereas, I've got, well, let's have a look at this. This is my test piece. I get a screaming signal off that 0.05, and I'll try and hold this some sort of logical thing. That bit there is bigger, and you can't detect it. So that is very, very strange. I think it's actually very close. It's probably thin. I haven't got it out of the container, but it's very, very close to my 0.1 in size. Oh, there it goes under the tape. We call that Murphy's Law when you're trying to show something. So anyway, I'll get there right side by side. If you have a look at the 0.1 and that, if I don't get the light on it, it's just want to reflect. It's about the same size, but that is very hard to detect with a pulse induction detector. So strange, isn't it? That's why you want a hybrid pulse induction VLF within reason. No matter how small a coil you would use on the VLF, sorry, not the VLF, the pulse induction. Even if you use a coil like that size, it would have a difficult time getting any signal off it because the eddy currents are decaying so fast. There's just no mass. It's probably very, very mottled, irregular, lots of surface cracks through that gold. That burns up the eddy currents. They don't generate to a level the detector will get them. I could actually mold up a piece of gold, metal, alloy, whatever, and if you actually put a whole lot of micro cracks through that metal, pulse induction detector, the more cracks and fractures it has, the less the detector will be able to hear it. It'll just eventually get to the point where even the size of a decent sized coin like that, you probably can't hear it. It's just that the eddy currents can't form on the outside, and the receiver's got nothing to listen to. It just burns up inside it. When I say burns up, it just dissipates. It's just such a low level that the eddy currents want to run around, but they keep hitting pits and valleys, and they just burn up as they go over it. Basically, dissipate, not burn up. Oh, we say burn up. It's a term we use in electronics for anything to do with magnetics, losses. So we should say dissipate rather than burn up, but I don't know, it's just one of those habitual things. Now, we've proved a point with that. What I want to do now, I want to see, as I've got a target here, which is, I would classify just about undetectable. I want to do an experiment. I'll do it on one of my own 4500s to see what I can do. It's going to be hard. It's going to be very difficult to do because you can't push the PI detectors too far frequency-wise. Basically, on and off characteristics, it'll just get into itself, and it's just not fast enough. It'll get basically the target signal, if there is any there, will get squashed out in the multiplexers. It'll just get baby out of the bathwater. But we'll try. I mean, I could try changing the filtering and all sorts, trying to get the signal level up on such a tiny piece of gold. I just haven't seen one of these types where it's specifically of the correct size, shape, and the amount of fracturing in that gold to cause it to be basically non-detectable. So it's something which is good in a way, because I can then run some experiments on it. I can have a look at the decay curves on the oscilloscope, and we'll see how fast they decay. I've actually got my 1.5 gigahertz LeCroy oscilloscope back. I picked that up yesterday. I went down to Melbourne. I wish I never went there, but I wanted my oscilloscope. I also picked up a whole heap of new parts as well for the detectors, specifically for the 6000s. I've got the 6000s I've got to do. The 6000s, one of our customers, I won't mention names. I'll mention his first name so I know who I'm talking about. Adam. He gave me one to do. He wanted to compare what the 6000 I did for him against a standard one, and did that, and he was impressed. So he gave me the standard one, and because I've had extra stuff which I can do, I put it in the other one, and obviously the last one I did outperformed the first one I did for him. So that's back, and it's been. I think actually it went to Dave's. I think he might even have it back, but well, of course he's had it back. Let me get my timeline straight. He's so many damn detectors come in the door. Okay, he's got it back. He has got it back, and he said that that one outperformed the other one, and now I've got to do the other one to the same as. Yeah, you know what I mean. I've got to bring that first one up to the same standards what I did for the second one. Have I got it here? No. David must have it, or it's been put somewhere. I don't know. Or did I do it and has he got it back? I don't know. Too many detectors. I've got boxes of things just waiting to get done. So without further ado, maybe I better go and look at what I've got to do, because sometimes it just gets dropped in and I just sort of stumble across it. Or there's boxes put there, I don't know what's in them. That's the other thing too. It could be anything. But yeah, I'm just having a look around to just make sure I haven't missed anyone's detectors and forgotten about them. No, I don't think so. But that will be interesting. I've still got this 7000 here, which I fixed. I got the 7000 going, by the way, but the display is getting worse on that detector, and I've got some new beefed up displays coming. Should be coming from FedEx and should be here on Monday. Gary, that's yours. So that should be taken care of on Monday, I hope. FedEx is usually pretty quick, so that's under control. I hope. I pray to God it's under control. Yeah, so I'm going to do an experiment with the 4500. See how fast I can clock the thing before it all, starts getting into itself and falls over. It won't work. If you push it too far, it won't ground balance, and it's going to have a hard time ground balancing. You're going to run into other issues as well. It's just that a lot of it is not made really to do that. You should have different damping. The damping resistor value should be changed if you start really playing around with the pulses. These are set internally, switched by a MOSFET, but they're 390 ohms, or am I thinking of something else? No, they're 390 ohms. I'm thinking about some of the coils, the double D coils that have something around about I think 580 ohms. I think they put in the double D coils. Got to try and remember all these numbers. It's damn difficult. But yeah, it's not optimum. Probably with the coil 300 microhenries and X amount of capacitance. Um, you know, time duration of the transmit pulses. Fudge factor, because you've got long ones and short ones. But it's they settled on 390 ohms. But maybe with running very, very short pulses, you get them very, very short, that resistor value should change to critically dampen the flyback and get rid of it quick, and then you can start moving the receiver timing up. Uh, if you don't dampen properly, what's going to happen? It's going to be a spread out dog's breakfast, and the receiver's going to crash into it, and it doesn't work. Won't work. So possibly on these, I think I said it before at one stage too, where you could probably put 2 or 3 switched MOSFETs on the back of the board, and have a switch and just gate 1, gate 2, gate 3. You can basically load different damping resistors across the transmit coil circuit, and you can optimize it that way. Haven't done that yet. Well, I did it a long time ago, but it was not on these detectors, it was on the SD2000s. And on the SD2000, I think I actually said, I'll stuff it, and I put variable damping in there. I just had 2 set resistors and a pot between it, but it had to be a hefty pot because it had to handle a fair bit of flyback voltage and current. And I had variable damping, so you could adjust it to what sort of coil. We were using coils up to 600 microhenries and slowing the detectors right down. So the damping, critical damping, had to change to get the benefit. Anyway, that's enough waffle on that. So I will experiment, and I'm not going to go and video all the experiments doing it, because it can take hours. Just be staring and you just see hands moving and parts going like this. You won't make any sense of it. So I'll just see if I can get it to detect that gold, and just see how far I can push one of these. It might be a very steep vertical challenge doing this, but I'll give it a go. I'll give it a go and see what I can do. I have some ideas, but it might end up being extensive modifications to do it. And I want to make sure that it doesn't affect the larger gold detection capabilities. So you can't just go and optimize it up here for this tiny stuff, and this stuff goes down down the drain. You want to cover it all. You want to cover it all. Otherwise, you can have angry customers. But this is our problem. So yeah, his complaint is it won't pick that up. Well, none of them will pick that up. So it's not really an issue. But because he's taken the time to send that in with his detector, I will investigate to see what I could do. But I'll do it on my detector. If I can get it working so it picks it up a lot better, then I'll do the same thing to his detector. So, and then it may become part of the standard range of modifications, as long as I don't have any effect on the larger, deeper gold performance of the detector. We don't want to go and put switches all over the detector. We say, oh, we have to change that to that, and that to this, and that to that, to get the small gold performance. Because by doing that, it just makes it so damn confusing for people. There's people out there who don't even know how to use the basic modifications. With variable gain and variable frequency, they get completely confused. And I look at that and say, how can you get confused? But I think back to when I first started detecting, and I had bounty hunters and Garretts and Whites and all these early detectors, even stuff I can't even remember the name of now. But when I first started out, I was absolutely confused, as in what did what and what interacted with what. Am I running this in the right mode? It would say, have a switch. It'll say VLF, then it would have TR and something else, and you go, oh God, what am I meant to be detecting in? What one? And normally, what I do is you just bury something and just flick around till it worked the best. But I do understand that. You start putting buttons and knobs all over the detectors, it'll just bamboozle people. They will just cringe. So try and keep it simple. That's why the Gold Monster's been such a big seller, um, especially overseas. That it's really basic. It's sort of turn it on. You really can't stuff it up. Um, any way you set that, it's going to detect gold. It's not going to really might lose a little bit of depth if you put the gain down too far, but it'll work. It'll work fine and very easy to use. So nothing wrong with that detector whatsoever. As soon as you go to these and anything with lots of knobs and buttons and menus and things, it confuses people. So in some cases, you could look at it. Even that SDC 2300 detector was just you really couldn't stuff that up either. And it's a PI detector. It does have a bit more punch to it, but that's what people want. A lot of the people who retire and go prospecting, they don't want to bloody try and use a supercomputer. They just want to, turn it on and go. You know, God, if I gave a metal detector to my mother, um, I think that she probably wouldn't have found the on and off switch in a month. It's just that there's a generation of people who just don't understand it. No, it's true. It is true because some of the people we deal with, well, we deal with all sorts, but some of them are pretty antiquated, like myself, and they just can't get the grasp of it. I've had them out in the field, and I'm just explaining it, and they just don't gel with how it's explained. They just got no idea, and you just basically, here, black dot. Make sure the switch is in the black dot position. This one in that black dot position, and that's how you use your detector. Just do that, because otherwise they have no clue. They don't work it out properly, and they have no confidence in the detector. And if you do not have confidence in your detector, you will not find gold. I'll tell you that now, because all you got in your head, doubt, 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 and your doubt will overcome anything you're listening to. So you won't dig it up. You just doubt it and say, oh, it's hot rock. It's a piece of metal, iron or whatever. You just won't dig any targets. Usually, you just walk over them all. But it's as much psychological as it is technical to a degree. Metal detecting, yeah, it's just what it is. Anyway, I've got some stuff to do. I'll do it, and if I can do it, I'll put it up. If it's a failure, and it all goes horrible pear shaped, I'll put that up as well, because then you'll see not to do it. Okay, catches.